Imagine a high school student who can balance complex chemical equations in their sleep. They've aced the standardized test, but ask them to figure out why the local river water is turning green, and they stare at a blank screen. Educators call this the theory practice gap. It happens when students master the textbook concepts, but lack the tools or know how to apply the knowledge to actual problems. For many learners, especially homeschoolers or those under resourced districts, the physical distance between home and a working lab makes exploration impossible. They are cut off from the scientific networks that turn curiosity into results. In this void, there are no mentors to guide experimental design. There's no access to professional lab equipment, and definitely no instruction on how to write a grant for funding. Even the most brilliant ideas are effectively trapped on the page. This disconnect doesn't stem from a lack of intelligence or drive. The barrier that keeps these students from innovating is a lack of community. That specific problem is exactly what our grassroots initiative out of Chandler, Arizona set out to solve. DRIBBLE stands for Dream, Research, Innovate, and Problem or Project Based Learning. This structured engine operates by dismantling isolation, plugging students directly into a thriving scientific ecosystem designed to move them past the textbook. The program operates on a 9-month pipe. It gives students a clear step-by-step pathway to transform raw theoretical curiosity into a validated real prototype. If we look closely at this table, we see that students have dedicated mentorships 120 minutes a week. That dedicated time connects learners to the entire network. They get feedback from subject matter experts, and they can even join those WhatsApp networks for continuous peer support and even submit to student-run academic journals. The 9-month curriculum provides the instructional sequence, and human mentorship ecosystem provides the momentum that carries students from theory into practice. You can see this from students like Brad Wu. By leaning into this exact mentorship framework, he developed a biomedical exoskeleton, work that earned him recognition as a National Davidson Fellow, or Sia Podar, who secured top scientist honors for her research and eventually took the stage to the TEDx stage. And here's Tyler Dong. He evolved from a standard high school science fair participant into a founder of his own startup, ShelfSmart. By embedding themselves in this global community, these high schoolers have transitioned into active founders and published researchers. We verified this with studying and tracking students um, over 3 years. And we found that there's some striking anomalies. In the top row, tier one students achieved 100. Here, hold on. So in the top row, tier one students achieved 100% state science fair qualification rate. And then if you move right, over a quarter advanced to the international fair, and every attendee secured an award. Here is another chart tracking grant writing. And it contrasted against traditional schooling. We see a massive divide. Tier one students showed a 94.1 participation rate in writing professional grants. Meanwhile, students in traditional AP classes in the bottom two rows sit at a 2 to a 0%. The math here is clear. Integrating students into a highly supportive community directly addresses the skills needed to move from study to innovation. Now, the organization is scaling to impact. This year alone, Dribble will bring 9 distinct student projects to the global stage at ISIP competition. They're likely expanding into territories like India and forming partnerships with groups like Technovation and the Shaw Marine Institute. And we're helping to empower individuals all around the world. Dribble demonstrates Dribble demonstrates that breakthroughs in student innovation depend on the strength and connectivity of the communities we bring around young minds.